Dear students, today we will be discussing data compression. So until now, we have learned that how to store data, whether it's a numerical form, textual form, or images, sound, etc. So now the time has arrived that we should learn some of the strategies that how we can store data inside the computer system by compressing it so that it can take little amount of little space within the computer system. So in fact, there are two major categories of storing or compressing data. So one is known as lossless, in which there is no loss of data, and the other is called lossy technique, that may lose data. So if we further elaborate lossless techniques, here we are interested to retain the original data as it is. So original data can be reconstructed from compressed data. So examples are, you might have used zip file format. So you have number of files, you use the zip software to zip it, and then at the end when you unzip that data, you need the same original data. So you are not expecting to lose some of the data. Then if you have source code, the written code of computer science programs, some in programming language, you have text documents, you have executable programs. So all of these type of data you need to reconstruct after compressing. So that's why we called it lossless. So there is no loss in the data when compressing. So the next is lossy techniques. So original data cannot be reconstructed from compressed data. Only approximation is possible. So we are going to compress the data, and we do not want to see, or we do not want to retain the original data when we decompress. So such kind of techniques are used in multimedia data, especially audio, video, images, and especially in the applications like streaming media. Then there is another kind of techniques known as run length encoding. So these are suitable where the long sequence have same values like 900 ones followed by 300 zeros. So instead of storing 900 ones and then 300 zeros, we can just say that this kind of data have 901 and 300 zero. So such an information can be said within a very small amount of space. And then the next thing is frequency dependent encoding. So length of the bit pattern used to represent a data item is inversely related to the frequency of the items used, and they have variable length codes. And such variable length codes have been developed and credited to Hoffman, and the codes which have been built by Hoffman are called Hoffman codes. So what are those Hoffman codes? Let's see. In English language, characters A, T, A, I are most frequent than Z, Q, X. So using smaller bit pattern to represent E, T, A, I would save the space. Then there is another approach called relative encoding or differential encoding. So stream of data differs only slightly from the previous ones. For example, in motion picture. So in motion picture, if you are want to compress the video, so you know that video is can be constructed by number of small frames of images. So if you want to compress, so you just need to store that what is the difference between a frame number 0 and frame number 1, and then what is the difference or change in frame number 1 to frame number 2. So you just need to save that change, and the whole picture can be stored once. So record differences rather than storing the whole frame again. Then there is another approach called dictionary encoding. store just a reference to a dictionary term, not the whole word, especially used by word processors as they have already dictionary for spell check. So such kind of approach is also known as adoptive dictionary encoding, in which dictionary dynamically change over time. When a large unit is found, it is added in the actual dictionary. One example is Lampelziv Welsh LZW encoding. So let's see what is this encoding over here. So you can see that we have such information. We want to store XYZ space and so on. So let's say we encode X as 1, Y as 2 and Z as 3 and this space as 4. So as it is adoptive, it will see that again XYZ has arrived. So it will give it one code like 5, and then there is a space which has 4, then 5, then 4. So this means you are not going to store 3 characters or 3 codes for XYZ. Instead, you are just storing one character, that is 5, against XYZ. So in such a way, it is learning adoptively, it is learning at the runtime, and then it is storing lot of space. So let's summarize today's module. We have learned the compression techniques. We have learned that what are generic data compression techniques, lossless and lossy techniques, and LZW with a suitable example.